Hey, my name is Jonathan Helm, and in this video I'll show you how to do multiple regression in R. So I'm going to continue this example using the salary dataset. So the first thing that I want to do is read the dataset into R. I'm just going to open up R on my computer. And so I have the console here. Make the font just a little bit smaller. I'll go ahead and I'll open up a new script. Okay, so a script to work with. Performing multiple regression in R. So first things first, let's go ahead and read the dataset into R. I'll use the read.csv function like I have in most of the videos on the YouTube channel. I'm going to right click the file, and on a Mac I'll hit get info. For a PC we'd have properties. I'll copy the path. I'm going to paste this into the read.csv function, include another / read salary data.csv. It's always a good idea to take a look at the first 6 rows of the dataset to make sure that everything was written correctly. I'll go ahead and open up the CSV file, which should open up as an Excel file. Zoom in just a little bit. Okay, so we can see that the first salary in our actual dataset is 83,404. The number of pubs is 3. The number of years on the job is 19. Female value is equal to 1, department 2, and so on. And if I take a look at the output in R, look at the output in R, looks like we have 83,404, number of pubs is 3, years on the job is 19, female is 1, and so on. So it looks like I read in the data correctly. And so now I can go ahead and continue to do multiple regression. Okay, so let's say I want to run a regression analysis where I'm predicting the salary using number of publications and years on the job. And so, as we saw in an earlier video, we can run a simple regression analysis using the lm function. So we can do something like model.o1 is equal to lm, and then I have the dependent variable salary as a function of an intercept plus a slope times, let's say, number of pubs. And we'll say this is in the data set called data. We'll say NA action equals NA exclude. So what I'm communicating to R is that I'd like to predict the salary variable, okay, and I'd like to predict that with the variable called number of pubs. And this is going to estimate an intercept, right? Like, for example, it's going to estimate the value that goes outside the 1, and it's going to also estimate the slope. Okay, but R knows to estimate these values, so we don't actually put them in there. Okay, so R will calculate these values for us. R needs to know where these variables are, so we say that salary and number of pubs are in the data set called data. And the reason why we choose this word data here, or this object data, is because we use the read.csv function up here. And when we read that data set, we stored it into this new object called data. So if I had written something else here, like my data or regression data or anything you want on the left-hand side, whatever we would have here, that's what we put on the right-hand side here. That's what we put right here. And so R would know to look for these variables, salary and number of pubs, in this data set called data. We're using the NA action to say NA exclude, which is telling R that if you have a missing value for either salary or number of pubs, to go ahead and remove that from the analysis. Now, this is a case of a simple regression, right? And this is a simple regression because we just have one predictor predicting the outcome. And so if we wanted to include in second predictor, all we would do is add another plus sign, and then we would insert that value. So let's say I wanted to do years on the job. I add years job here. So R will run this whole regression analysis. It'll estimate the intercept, a slope for number of publications, and a slope for years on the job. And it'll summarize all of that output and store it into this object called model.o1. If I highlight and run this, we'll take a look at the output here. So it ran the model, it stored it in model.o1, and we don't get any errors back, so it looks like everything has run as we expected. And now if we want to look at that output, then we need to use the summary function. So we'll do summary of model.o1. If we highlight and run that, then we get some output. All right, and so this is the estimate of the intercept. This is the estimate of the intercept. This is the estimate of the slope for number of pubs. A little bit of trouble highlighting things. And then we also have a slope for years on the job. So what does this mean? Well, of course, the intercept is our predicted value of the outcome when all predictors equal 0. So this intercept is the expected salary for an individual who has 0 publications and 0 years on the job. So they just started their job. So we expect that person to make $72,028 a year. And then for every 1 unit increase in number of publications, we expect the salary to increase by about $2,700. And for every increase in year on the job, we expect the salary to increase by about $1,640. Okay. Now if we scroll down, we see the multiple R-squared value down here. And this will tell us the proportion of the variability and the outcome that's accounted for by all of the predictors simultaneously. So about 60.35% of the variability in salary is accounted for by number of publications and years on the job. Okay, so those two variables together are both counting for a total of about 60% of the variability. Okay, so that's all I'll do for this video, and that's how you do multiple regression in R. If you wanted to add more predictors, then all you would do is add another plus here and include the next variable name. So it's really just a very simple extension of simple regression. You can just add as many predictors as you want to the right-hand side of the equation, and then everything else stays the same. You'll run the analysis the same way, store the output and the object on the left-hand side, like model O1 in this example, and then to take a look at the output, you'll just use the summary function. Okay, thanks for watching. If you liked the video, go ahead and like it. If you have any other comments or questions, feel free to add those to the responses below. Of course, feel free to email me at jonathanleehelm@gmail.com, and you can also follow me on Twitter at jonathanleehelm. Hope you enjoyed it.